So this one was a pop quiz 10, which was related to bonding and structure. Aluminium chloride can exist as a dimer formed from two molecules of aluminium trichloride. Draw a diagram of this dimer and showing the bonding between the two molecules, like how the two molecules are linked with each other in aluminium trichloride. And dimer here, like when two molecules are together and linked with the dative bond, we call them as a dimer. So how we represent that? So aluminium, even though it is a metal, but in case of aluminium trichloride, there is a sharing of electron rather than transfer of electron. This is exception. So aluminium shared electron with chlorine, like 3 covalent bonds are there. Each chlorine share 1 as it belongs to group 7, and unshared electrons will be 6. This is a one molecule of aluminium trichloride. Then another molecule of aluminium trichloride. So aluminium is there. Then a dot and cross diagram. So it has a covalent bond and a dative bond. This is another molecule of aluminium trichloride. But now aluminium is not stable. Why it is not stable? Because to be stable, it must have 8 electrons in the outer shell. So how it gain the stability? So there is a coordinate covalent bond or a dative bond. Like one of the lone pair is attracted towards aluminium and it will form a bond. And here also one of the lone pair on chlorine is attracted towards aluminium and it will form a bond. So they like three of them are covalent bonds, normal covalent bond like this one between chlorine, all three of them are chlorine. Dative bonds between chlorine and aluminium, and one of the bond, they are covalent bonds, and one of the bond between the chlorine of another molecule with aluminium. The lone pair on the chlorine are attracted towards the aluminium, and this attraction leads to a dative bonding. So that's how we draw the structure of aluminium trichloride, AlCl3, because the ratio 2 aluminium and 6 chlorine are there. So when we take a ratio, it will be AlCl3. So this is the exceptional molecule. Like you don't have all the molecules of the metal be like this, but this is exception case. So you have to learn the structure of aluminium trichloride. Is it clear, this one? Then describe the metallic bonding in aluminium. How we explain the metallic bonding, and it's of 3 marks. And then explain how the metallic bonding leads to a properties of electrical conductivity and malleability. So first, how we describe the metallic bonding. What is actually a metallic bonding? It is strong electrostatic force between the positive ions or the lattice of a positive ion and the delocalized electrons. And what happened in this structure? Aluminium lose 3 electrons per atom. So if you have one aluminium, it will lose 3 electrons, and when it will form, like if there is one atom of aluminium, it will lose 3 electrons as it belongs to group 3. Then explain how metallic bonding leads to a property of electrical conductivity and malleability. So electrical conductivity, why it can conduct electricity? Because of the presence of the free electron. That's why it can conduct electricity within the structure. And the second thing, layers can slide over each other without breaking. So layers can slide over each other without breaking. That's why it is malleable. And why it is a good conductor of electricity? Because of the presence of the free electron or a delocalized electron. That is why it is a good conductor of electricity. And malleable because the layers of the ions, the positive ions, can slide or slip pass over each other. So this was a pop quiz. It was related to bonding and structure.